Guys, we are going to discuss problem number 80, which is remove duplicate from sorted part 2. Question is pretty simple. Basically what you have to do, you are given array nums and you have some elements which are duplicate. So you have to return an index. So first let me tell what this question is saying basically in a layman terms. You have array, there will be duplicate terms. Some elements may have a single occurrence, two occurrence, or multiple occurrence up to n. Okay, basically what we have to do, we have to construct a new array such that a element can have at most two occurrences or less than two occurrences. Okay, like the one is having three occurrence, so at most it can have two, so we will have two occurrences of that. Two is have two occurrences, so we'll have two only. Three have two occurrences, we'll have three two times. Or if I change this, if there will be a 4, so basically what we'll do, we will have 4 one times, because its occurrence is less than 2. We will reduce its occurrence if it is greater than 2. And there's one more thing, so you leave the last position empty, or you can put anything, doesn't matter. And what you have to do, you have to simply return the index till which position your array is solved, or you have removed the duplicate as per the question. Like you solve this array until this position your duplicates are removed, so it will be 0 1 2 3 4 5 6. so you will return say 6 index till 6 your array is sorted. Okay, so let's solve this question. It's a pretty simple question. Actually what you have to do, if you look at the question carefully, like you have to just figure out if a number is having occurrence of 2 less than 2 or more than 2. Till 2 it's fine. If it is having more than 2, what you want, like you see 1 is having occurrence, I'll keep a track of count. It is having occurrence 1 2 3, so 1 having 3 occurrence, so 3 is a problem. So what you have to do, you have to put the next element, this element, at the after the second count of the one element. Basically what you have to do, you have to do everything in place without using a space, and space complexity should be big of 1 constant space. Okay, so basically 1 is having count 3, we don't want that. Till 2 it's valid. After this we have to put a new element or the next element. So element that we can have is this 2. So till 2 it was okay, we'll put 2 here. This 2 will be as it is, this 2 will be as it is. You can see, let me remove 4. Okay, then we will keep track of count of 2 occurrences, this 1 2 and 3. Till 2 it was okay, till at 3 it's a problem. What do you want? Put a new element. We can find 3 here, we'll place it here. Okay, after placing it here, 3 will be here. Okay, now occurrence of 3 is 1 2 3. Till 2 it was okay, at 3 there is a problem, so you will keep it here, we'll keep a pointer here, and you will return this position. So I hope you understand what it's the basic of the question and developing the intuition. So the first thing that you understand, like till 2 occurrence it's okay. If it is greater than 2, you have to put new element, or the element just or the new element just after that element. Okay, or we can have another better example that I'll prefer to take this. So output for this will be pretty simple: 1 twice, 2 will be twice, 3 will be twice. Okay, and rest you can have anything till this index. It's your answer is valid, or you can return this index also. Before this index, answer is valid. Let me just check which index it was asking. Return k after placing the final result in the first k slots. Return k first k slots, so we have to return this. 0, 1, 2, 3, 4. So yeah, we have to return this index. The till where array is sorted or array is solved. Sorry, removed the duplicates. First thing that I said, you have count equals to 2. You have to put the new element. You can use hash map, but that will be using big O of n space complexity. So rather I'll explain or give you a better approach. I shouldn't have got this. Okay. Or rather have it. So okay. Like what you can do, you can keep a pointer here. If it is at 0 index, like if your I is at 0, you don't have any problem, because the occurrence of any element here will be at most 0, or sorry, at most 1 at the 0 index. If we keep an I here, we still don't have any problem, because at most the occurrence of any element can be 2. For example, this position and this position, at most. Problems arise when we are here at the second index. Like we came here, okay, and we have some another pointer j. You can see j is traversing in a linear time. I is just checking or tracking the if we have 2 elements or not. The occurrence of that element is 2. So what we'll do, like the thing we can do, we can check 2 position behind this element. Like how you'll find if this one has occurred more than twice before this. Basically what you can do, you can check before this before this index. For example, you can see at the second index this one. What if at 0 index or before 2 index, before I minus 2 index, or just before 2 index, you can say we found out the same element. Okay, if we found out the same element, then this element is repeated, so we have to switch this element. We want some new element in this position. Okay, so basically we will check key element at this position, which is 1, is it same to the element at the I minus 2 position, nums of I minus 2 position, which is 0. Yes, these two are same. Now if we found out the occurrence is more than 2, can be 3, can be 4, or n number, but we found out it is more than 2. So we want a new element, which like in this case is 2, to be here. So what we'll do, we will come here, we will check if this element is same as this, sorry, this, if this is same, so we'll move to the next element. So you came here, basically, like you came here, you will check if you found out a new element or not. Like if your, like, just think, you have the position where you want to put a new element, you know Before this you had 1 having occurrence 2. Okay, so this is making occurrence greater than 2. So basically you want a new element to just come here and to remove the duplicates. So what you'll do, you will check if nums of I minus 2 is not equals to this position that currently is pointed by nums of j. You can say if these two are not same. What does it mean? You found out a new element. If you found out a new element, you want to keep it here basically. uh, Let me rub this. So you'll keep it here, you'll put 2 here. So this position index 2, you can see it is sorted. You have removed the duplicate here from at this index. Then what you'll do, you'll come here. You came here, what do you saw? uh, After removing, you'll increase a I because this portion was sorted. Then what you'll do, your element or your j will be here basically. Then what you thought, we will check simply if this element at the at index is having occurrence more than 2 or not. But simply you just check before this, or you will check at the I minus 2 index, nums of I minus 2 index. You saw this is same as this basically. Okay, so it is same. Then what you want a new element to put here. So basically what you will do, you will check if nums of I minus 2, basically it means at this position, is it same as the nums of j, the current that you have. So these two are not same. So what you'll do, you'll put this value up here. I know it sounds tricky, but it just boils down to keeping track of the count of the element. If count reaches greater than 2, we want to place new element. Okay, and to check the count, we put I minus 2 as I said. And to put the new element, what you'll do, you'll search until you found a new element which is not equals to the value that is pointed by I minus 2. Why we are doing I minus 2 rather than I minus 1? As you saw earlier, 1 was here, okay, and j was here. So if you did I minus 1, you will check with this. So what you do, is 2 equals to 2 or not equals to 2, which will be 4, so you won't be able to solve. And so basically what does it mean? Rather, you don't know if this position is sorted or not, or the next position is sorted. So basically you look for I minus 2 at position rather than the I minus 1 position. So let me take you to the coding part.
So hey guys, this was the question, and you can see it was written do not allocate extra space for another array. So let me show you the code. It was pretty simple. Ignore this one. So basically you'll have a pointer which will point at the position you want to replace. Points to position you want to replace. Okay. And basically what we are doing here, we are getting an element, and in this loop what we are doing, if it is at 0th position, you don't have any problem. If it is at 1 position, you don't have any problem. And the main thing is, if if we are standing here, and for example if we are standing here and the element is not same as the I minus 2th position, so we want to replace it and increase the value of I. So if you can understand, like I will be here in the case and an element will be here. So we know we want to put new element here, and how you will get a new element at this position, second index. It is pretty simple. If the value that we have, the element ele, is not same as the I minus 2th position. If it is not equals, it means it is something new, some new value has arrived. So basically we'll put that new value here, we'll increase our I to the next position, and at last we'll return the position till where your array is solved, or you can say removed, you have removed the duplicates. Let me run this. This is accepted. So thank you for watching.
You can subscribe to my YouTube channel. Bye bye.
I don't believe in destiny. I just